We're going to go high-tech, guys, with some crazy computer graphics here. What you hear without a silencer, so if you just have your gun and the bullet's coming out, as soon as the bullet comes out of the barrel, right behind it, a bunch of hot gas comes out at a higher pressure than ambient air pressure. So what you're hearing right here is high pressure gas expanding into ambient pressure atmosphere. We compare it a lot to like a balloon pop. If you were to pop a balloon and it's a sudden expansion of gas, you hear a pop. If you were to untie the balloon and let the air out slowly, the pressure relieves slowly and it makes much less sound. The other thing would be like a champagne bottle. If you pop the cork, that sudden expansion of pressure is what you hear. If you let the cork up slowly and let the gas escape slowly, it makes almost no sound. Maybe a little hiss. That's what you're going to hear for the most part from a gun. The other sounds that a gun makes, depending on the type of gun, is action noise. The other thing you get right here is what we call a sonic crack. If the bullet exiting the firearm is faster than the speed of sound, about 1,050, depending on your environment that you're in. So those are your basic noises that a gun can make. So you have exit pressure from the burnt propellant, you have the sonic crack, and the action noise. So with that in mind, there's not a lot we can do about action noise besides changing the type of firearm that we have. So if you want your gun to be quieter and because of the action noise is too loud, you have to change the style of action. As far as the sonic crack goes, we can get this to go away by manipulating our ammunition, going heavier bullets at a slower velocity to make it what we call subsonic. So we can make sub ammo that is quieter than supersonic ammunition due to the whip crack sonic boom of the bullet. So those are the two things that we can manipulate without a silencer. What the silencer deals with is this exit gas pressure differential. So internal chamber pressure, depending on the cartridge, there's cartridges at 60, 70,000 psi chamber pressure. Exit pressure is thousands of psi, depending on a lot of variables there, ammunition, barrel length, bullet weight, all kinds of stuff that can alter the exit pressure of the spent propellant gas. So what the goal of a silencer is to reduce the pressure. We want to reduce the exit pressure as much as possible. We want this as low as possible. Pressure, the lower the exit pressure, the quieter the firearm is going to be. So as the bullet is leaving the barrel, the gas coming out of the barrel goes into the first stage of a suppressor, which is normally referred to as an expansion chamber. The first area is normally a little bit bigger than the rest of the can. Now there's several different can designs here. This is a very generic suppressor. This is an expansion chamber. The bullet comes in here, the gas expands. By the time the bullet gets to here, the pressure inside here is lower than it was when it first exited. So if you were to take the rest of this can off and you were to have just a big expansion chamber on there, it would actually quiet the firearm down. To what degree it would quiet it down is going to depend on the volume of the expansion chamber. A good example of this is the movie style Coke bottle on the end of the 3-liter Coke bottle on the end of the gun. They tape a Coke bottle at the end of the gun. What that does is the bullet's coming out, that gas is allowed to expand inside of the Coke bottle, then puncture the outside of it. So it's like it fills up that chamber and then ruptures the outside. It will actually suppress a firearm to some degree. It's not going to be obviously as effective or have as much durability as a regular suppressor. But the gas is going to become very turbulent inside here. It's going to bounce around these baffles. It's going to dissipate heat. Very important point there. A lot of guys don't pay attention to heat dissipation. It will dissipate heat, bounce around in here, and increase its volume. The volume that was in here versus the volume that's in here, you can see this volume is much larger than that volume. So you're increasing the volume this gas is bouncing around inside here. The bullet exits. Behind the bullet, the gas exits now at a much lower pressure than it would have exited out of the end of the muzzle. So basically how a suppressor works. Now let's talk for a second about the physics that govern what makes a silencer effective. Everything is going to revolve around pressure, and the ideal gas law states that P equals nRT over V. And what this means is the pressure is equal to N being the number of moles or the number of molecules of gas. R is a mathematical constant. We can forget about R because it's just a mathematical constant. T is temperature, V is volume. So the lower the number of molecules, the lower the temperature, and the larger the volume, the lower the pressure is going to be. So the lower number of moles, lower pressure, higher volume equals lower pressure. Lower pressure equals lower volume, sound volume. So the pressure you can think of as the noise. Number of moles can be directly related to the caliber or how much powder is behind the bullet. T, temperature, big wild card, we'll talk about in a second. V, volume, is basically how big the can is, the size of the suppressor, size of the can, and T for temperature. Okay. So if we want to make our pressure lower or our sound lower, we can go from a 300 Win Mag to a 308. That would reduce the amount of powder or the amount of spent gas that's going to exit the gun. Pretty straightforward. 223 has a lot more powder than a 22. Number of moles. Volume, if we want to make the suppressor quieter, generally speaking, we can make the can larger, have a larger volume. And then temperature. There's a lot of things that we can do with temperature. What we try to do with temperature, one of the things that we do are these baffles inside the suppressor. These baffles that are in here, the longer the gas is able to stay inside the can, the more heat the suppressor is able to draw from the gas, thus lowering the pressure. If we can drop the temperature, we can drop the pressure, which means we can drop the noise. So that's one way of doing it. The other way we can lower the temperature is by running a can wet can. What can you use for wet cans? We'll do a whole video on wet cans by itself. But basically what you do is you introduce a small amount of water, oil, grease, gel. There's several different things that you can use inside a suppressor to help the gas transmit heat to the suppressor or to the liquid that's inside the suppressor. Some of the older cans, what they used to use is what's called packing. And what they would do inside the can is they would take a suppressor that had baffles and they would fill it with packing. Fiberglass, steel wool, there's all kinds of stuff that you can use for packing. And what this gave you was additional heat sink as the gas passed over that steel wool, over the fiberglass, over whatever the packing was. It would draw heat away from the gas, thus lowering the temperature and in turn lowering the pressure. So that's the basis of how all cans work.